All right, we're gonna try. All right, so this homework help video is for people that missed the other homework help video that I created in week 7. Okay, so I already did this, but I'm gonna give you a refresher video. All right, so Monday, all we did was classify if it was a positive correlation, negative, or no correlation. Positive correlation if the points are going up, negative if the points are going down, and no correlation if the points are everywhere. So look, the points are everywhere here. That's why I wrote no correlation. The points are going down. That's why this is a negative correlation. Sorry, this is no, this is negative. Positive correlation because the points are going up. This is another positive correlation because the points are going up. Negative correlation because the points are going down, and no correlation because look, it's a circle. The point, you can't tell if it's going up or down. It's everywhere. All right, so here you got a table. X is the hour study, Y is the grade. So you're going to graph the points in the scatter plot. Okay, so I'm going to start at, this is the hour study along the bottom, 0, 1, 2, 3, 4, 5, 6, 7. And then I'm going to put a break in the line and start at, what's my lowest number? 60? 60. And then I go up 60, 65, 70, 75, 80, 85, 90, and then 95, 100. So I'm going up by fives. I just wrote every other number. And then I'm going to take and graph these ordered pairs. So then when I graph the ordered pairs, after I graph, you can pause the video and go ahead and graph these ordered pairs. Okay? Okay, so we have it graphed. Good. You graphed them. Now it's saying you need to predict the grade. Okay? So now in order to predict the grade, you got to do line of best fit. So 2 ways to do a line of best fit. You can pick 2 points. Okay? Pick 2 points from the graph. Then write those 2 points down. The 2 points you choose should make a line that is in the center. So make sure that you choose 2 points that when you graph those, when you draw a line through the center, when you connect those points, the line is in the center. So choose 2 points. You got 2 points chosen?
Yeah, 0, 6, 0, comma 6, and then 4, comma 90.
And then 4 comma what?
90.
90. Okay. So now you can write the equation by using the slope formula. So the slope formula, that's 90 minus 6 on the top, and then 4 minus 0 on the bottom. Y2 minus Y1 over X2 minus X1. So what's 90 minus 6? That's going to be 80 what?
84.
84. So we got 84 divided by 4. So what is 84? What is 84 divided by 4? Yes, it's 21. So we're going to put 21 for M. Okay? And so M here is equal to 24. 21, sorry. Now my B, my y-intercept is where x is equal to 0. This is the y-intercept right here. You see it? Okay. Oh, you said 0 is 0 and 60, babe. 0 and 60, not 0 and 6. I was like, where did 0 and 6? So let's do 60. That's okay, babe. So let's do 90 minus 60. So that's going to be what? 30, right? All right, so now we got 30 divided by 4. What's 30 divided by 4?
7.5.
No, 7.5. That's better. 7.5. And B is going to be 60. Do you see that?
Mm-hmm.
All right. So to write the equation is going to be y is equal to 7.5x plus 60. You see it? Okay. So now, to make a prediction of what the grade is going to be, we're going to substitute 6. We're going to substitute 6 in the place of x. Okay? So we're going to plug in 6 here. So that's 7.5 times 6 plus 60 and see what that grade is. Is it going to go on forever? No, it's not going to go on forever because the highest grade you can get is 100. Okay? Any question? Okay. All right. So now, down at the bottom, you are going to graph these ordered pairs. So when you finish with this, graph the ordered pairs. Okay. Okay, so now in order to do this line of best fit, we did this before, but that's okay. Remember, I said this is a review because I already did the homework help video. That's why it's already filled out. Okay. All right. So in order to get the line of best fit, you clear your calculator at second plus 712. Okay. Let me know when you have it. Okay. And now you're gonna type in the x value is gonna go in L1, the y value is gonna go in L2. So go to stat and go to edit, and let's type in the hours studied under L1. Okay. Let me know when you have it typed in. Okay. Okay. So after you type the ordered pairs in, now you're gonna go back to stat and then go over to calc and do lean rig number 4. Does that make sense? And then press enter. And this is your equation. I'm going to just truncate. I'm going to cut the decimal off after the second number. So that's why I put 5.42x. And then the y-intercept is 76.4. Do you see it? Do you remember? Do you get it?
Yeah.
Okay. So now remember, to find the correlation coefficient, you have to do the diagnostic on. So the catalog is here. So you press the yellow button and 0. That goes back to the catalog. So from the catalog, you're going to go all the way down to diagnostic on. Do you understand?
Mm-hmm.
And there's 2 of them, so make sure you press diagnostic on and enter. You get it? Okay. All right, and then press enter so it's done. So now do the same steps again. Do linear regress. That's stat, calc, lean reg. And when you press enter this time, it's going to give you the R, the correlation coefficient. This tells you how strong it is. So this is 0.7. So as long as it's between 1 and 0.75 is strong. Between 0.75 and 0.5 is moderate. And between 0.5 and 0 is weak or no correlation. Got it? All right. So this is going to be a strong one. And it's positive because it's it's going up. It's a positive number. Does that make sense?
Mm-hmm.
So this is a positive strong correlation. All right. Does that make sense? And a positive strong is going to be between 1, it's between, R is going to be between 1 and 0.75. That's a strong. Got it? All right. Make sense? You okay?
Yeah.
All right. The question at the end says you're going to make a prediction if you studied for 4 hours. So that means x is equal to 4. So you're going to plug in 4 into the equation and then solve this. You can multiply 5.42 times 4 plus 76.4 and see what you get for y. That's your prediction. You got it? Okay. You can go ahead and do that and see what you get. All right. So now we're going to do Tuesday. Okay. So with Tuesday, they already gave us a line of best fit. So we're going to use that regression line, a line of best fit, to construct or to find residual. The formula for finding residual, okay, or let me explain what residual is first. Residual is going to be how far actual points are away from the line of best fit. So an example would be if I have a scatter plot, and on my scatter plot I have these points, right? And my line of best fit, of course, is in the center. Okay, we got 1 point that's on the line. Okay, so my residual for this point right here is a positive number because it's above the line. So this has positive residual. And whatever this distance is, if it's 1 away, then the residual for this point is +1. This residual for this point might be 2 away from the line. So it's +2 because it's on top. This point is below the line, so the residual is going to be negative. It might be 2 away from the line, so my residual here is -2. My residual for a point that's on the line is 0 because it's on the line. It's no distance away from the line. So this residual is positive, maybe +2. This residual might be -2 because it's under the line. Do you understand? So residual is how far a point is, or that particular point is, away from the line of best fit. Does that make sense? Okay. So we're going to find the residuals for each of these points. So to find the residual for each of these points, I need to know what the points are on the line so I can subtract them. So what you do, residual, the formula is your actual y value. So you got your actual y. You're going to subtract it from the predicted y. And those are the y values that are on the line. So actual y minus predicted y. That's residual. Okay, got it? All right, so this is how you do that. Pause real quickly so I can. All right, so now we're going to type this in the calculator. I'm going to clear my calculator, 2nd plus 712, because I got all that stuff in it. So now you're going to go to y equals, right? And type this equation in, 0.5x. Okay, got it? What you looking for? You got it?
Wait.
0.5, put 0.5 and x. That's okay. All right, so now you want to know what these predicted values are that are on the line. So you're going to go to the table, second graph. So now you're going to look for the y value when x is 5. So look, instead of, let's fix our table so that it automatically goes up by 5. So go to table set, that second window, and we're going to go to table set. We're going to start at 5, and then we're going to go to the next line and go up by 5s. Got it? Now press second table, and now it's going up by 5s. Does that make sense? All right, so now let's put our predicted values in. When x is 5, the predicted value is 2.5. When x is 10, the predicted value is 5. Make sense? When x is 15, the predicted value is, good job. When x is 20, the predicted value is 10. When x is 25, the predicted value is 12.5. When x is 30, the predicted value is 15. Okay, so now we're going to get our residuals. So remember I told you residual is how far your actual points are away from the line of best fit values. So you're going to say actual, this is the actual minus the predicted. So 3 minus the 2.5. What's 3 minus 2.5? Mm-hmm. That's point what? Positive 0.5, right? What is 4 minus 5? That's going to be a negative residual.
-1.
Negative 1. You're right. what is, and let me go back to the main screen mode, second mode. Then we got 9 minus 7.5, 1.5, positive 1.5. So this point is above the line. Then 7 minus 10. What's 7 minus 10? It's 3 below the line. Then what's 13? And I know you know this. 13 minus, what is that? 12.5? 12.5, what's that?
0.5.
Positive 0.5. It's above the line. This point is above. And this is 0. This is a point that's actually on the line. You see how they're the same? All right, so now we are graphing just the residuals. So that means we're graphing the residual value as our y and, of course, the x value. Okay? So we're going from 5 to 30. So this is 0, 5, 10, 15, 20, 25, 30. Got it? And we're graphing these. So we're going, the lowest value is a negative 3. So negative 3 is, let's see, 1, 2, 3. It's negative 3. So we're going to go down. We got, this is 0, negative 1, negative 2, negative 3. Then this is positive 1, positive 2, positive 3. Okay. So now we're going to graph our residuals. So we got 5 is here, and 0.5 is up halfway, right here. Okay, so that's this point I graphed. So now I'm going to graph this residual, 10 and negative 1. So 10 is right here, negative 1 is down 1. Okay, then I'm going to graph this residual for 15, which is positive 1.5. 15 and go up, 1.5 is right here. Then I'm going to graph this residual, 20 and negative 3. 20 and negative 3 is down here. And then I'm going to graph this residual at 25 and 0.5. This is 25, 0.5 is up this way. So see, what I notice about my residuals is that I have just as many points on top of the line as below the line. I got 2 below and 3. So do you see how this is kind of a strong correlation? Because the closer to the 0 line I get, the closer the points are to the actual line of best fit. This, I have no idea, baby. Sorry. Do you understand that? Does that make sense? Okay. So are you okay with it?
Mhm.
All right. So let's do the second one. Did you finish graphing? Okay. All right. So let's go back to y equals, and let's type in clear and type in the next line of best fit. Okay. So this is the equation. Make sense? Let me close the door because I can hear that. This is second graph. Okay. Good job, babe. And so now this is going up by 2s, isn't it? 2, 4. So go to table set, second window, and this time start at 2 and go up by 2s. Do you see? Table, second window. Start at 2 and then go up by 2s. Okay?
Mhm.
And then second graph. So now we're writing our residuals here. Not residuals, our predicted values. So for 2, it's going to be 15.5. It's far away. Woo, that's far, ain't it? For 4, it's 14.7. For 6, it's 13.9. Oh my God, did I type that equation in right? It's weird, ain't it?
Yeah.
That is, yeah, it's right, but it's looking terrible, ain't it? All right, let me go back to my table. For 8, it's 13.1. For 10, it's 12.3.
12 is 11.
This is a terrible line of best fit because you see how there are no negatives. Well, we don't know that yet, so let me not say that. But let's see how close they are. Let's see. We're going to be hopeful, right? All right, so let's do it. It's just so far away. Remember, it's actual minus the predicted. So let's go main screen. We got 5 minus 15.5. Okay, this is so far away. Negative 10.5. Gosh, right? But then we got 15. This is closer, so this is better. Minus 14.7. That's that's 0.3. So that's good. That's close, right? But now we got 26 minus 13.9. That's 12.1 away. That's a lot. We got 23 minus what's that? 13.1. That's kind of far. That's 9.9 away. That's far. Then we got 11 minus 12.3. That's closer. That's negative 1.3. Okay, that's all right. And then we got 3. This is far. Minus 11.5. Negative 8, right?
Yeah.
0.5, right? So these numbers are kind of far away. I mean, this is probably the best line of best fit that they could get, but it's so far away from the line. These points are not very close together. Does that make sense? Okay, so this is not, this is a weaker scatter plot because the points are further away. Does that make sense? All right, so now we're going to graph the residuals again. We got from 2 to 12, so let's go up by 2. That's 0, 2, 4, 6, 8, 10, 12. And then the highest is going up 11, 12, 1, 2, 3, 4, 5. Even if I go up by 2s, that's not going to work. If I go up by 3, that's going to work. So let's go up by 3s now. So this is 3, 6, 9, 12, and 15. Okay. This is 0. Negative 3, negative 6, negative 9, negative 12, and negative 15. That fits all of them on there. You see? Okay. So now let's graph the residuals. It's going to be our Y value. And of course, the X values. Okay. So now we're going to graph 2 and negative 10. So go over to 2 and down to negative 10.5. This is negative 9. Negative 10.5 is somewhere in here. So graph that one. 4 and 0.3. So this is 4 and 0.3. Positive 0.3 is up a little bit, just a little. 6 and 12.1. This is 6 and 12.1. This is 12 and 12.1 is just a tad bit above. And then we got 8 and 9.9. This is 8 and 9.9. This is 9. And 9.9 is somewhere in here. We're estimating. We got 10 and negative 1.3 is a little down. And then we got 12. This is 12 and negative 8. This is negative 9. Negative 8.5 is somewhere in here. Okay. Do you see how far it is away from where this would be on the line? These residuals are kind of far. Okay. Does that make sense? So that's what you say. This is, the points are close together. So this has a strong sense. Okay, the points, I forgot to answer this question. The points are ordered pair are close together. So we know that this is a stronger correlation. So it's a stronger correlation. Strong correlation. Okay. And since the points are going up, it's a strong positive correlation. Okay. Now, These points, on the other hand, this is weaker because the points are spread out too far. This is a weak correlation. It's a weaker correlation because the points are spread far apart. Further apart. Make sense? So that's what makes it a weaker correlation. Are you okay with that? I'm pause with the cows. Okay, so this is Wednesday. You can finish up the other one on your own. Let's look at Wednesday. Okay, so with the factoring again, remember I already made a video for this. That's why it's already filled in. But I'm putting it, I'm making another one because somebody requested it. Okay, so I'm gonna do this one. You have once it's already factored, you have to set each of the factors equal to 0 to solve, and you have this on your paper, so you're doing good, babe. So we got a plus 1 is equal to 0, and a plus 2 is equal to 0. So to solve, you set each of the factors equal to 0, okay? So this, you're going to subtract 1 on both sides. This gives you a is equal to a negative 1. You subtract 2 on both sides. This gives you a is equal to a negative 2. So it crosses the x-axis at negative 1 comma 0, and it crosses the x-axis also at negative 2 comma 0. So this is where it crosses the x-axis. The parabola crosses the x-axis at these 2 points. Okay, so now let's look at one like number 6. With number 6, you see you have a number over here. This number has to be 0. Why does it have to be 0? Because if we're trying to figure out where it crosses the x-axis, your y value has to be 0. Okay, because every point on the x-axis has a y coordinate of 0. So in order to make your y coordinate here 0, you're going to have to subtract 5 on both sides of the equation. So when you subtract 5 over here, this gives you n squared plus 7n, and this is plus what? 10. Now you can factor that, okay? So you see this first number here is automatically a 1. So you're going to assume that you're going to have two binomials. You're going to put n in each. You're going to multiply the first coefficient, the leading coefficient of 1 times 10, which gives you a positive 10. The middle number is a positive 7. So you're going to think, what two numbers can be multiplied to give me 10, but when I add them, I get a sum of 7? So let's think, what two numbers can be multiplied to give me 10? 5 and 2. 5 times 2. And when you add 5 plus 2, you also get a positive 7. So you can use plus 5 and plus 2. Okay? So you're going to set each of these factors equal to 0. This is n plus 5 is equal to 0. This is n plus 2 is equal to 0. So now you're going to subtract 5 here to get n is equal to a negative 5, and subtract 2 here to give us n is equal to a negative 2. So where does the parabola cross? It crosses in two locations. One is negative 5, comma 0, and the other is negative 2, comma 0. You got it? Make sense? Okay, and that's what you're doing for all of these. Does that make sense? Are you okay? All right. So let's do the last page, and then I can conclude the video because this would have helped them. All right. So, and again, it's filled in because I've already did the homework help video. Okay. So you're finding the vertex. The vertex of these parabolas is either going to be the highest point, which means this highest point is the max, it's called the max value, or the lowest point of the parabola, which is called the minimum value. So here, my max point is 0, 4. That's the highest point. My minimum point is 1, comma, negative 1. Go over 1,
Please
comma,
pardon this
negative.
interruption. Here's the
Okay.
name and please
Got
come to
it?
the front for checkout. Here's the name and please come to the front for checkout. Thank you.
All right. So now your domain is always going to be all real numbers for all quadratic functions. Why? Because whether it's going up or down, it's going to continue to get wider forever. So that's why it's always going to be all real numbers, all real numbers, all real numbers, all real numbers. Because it's going to keep getting wider and wider. It's going to go on forever. It's going to keep getting wider, which is the x-axis. Okay? So now your range is always going to be, it's going to be infinity, either negative infinity or positive infinity on one of the ends, because it's either, if it's a downward U, it's going to be negative infinity because it's going to keep going down forever. If it's an upward parabola, it's going to be positive infinity because it's going to keep going up forever. Do you see it? So this is downward, it's going to keep going down forever. This is upward, it's going to keep going up forever. Does that make sense? All right, so the height is going to be, remember how you take a person's height is you start from their foot. Like if you're taking a person's height, you don't go from the head down, you go from the ground. You go from the ground up to measure a person's height. Does that make sense? The ruler starts on the ground and you go up. So that's why you go from down to up. So that's why negative infinity is first here, because you're going from the bottom of your parabola up. And since this is going on forever and ever, it's negative infinity to the tallest place on the y-axis, which is 1, 2, 3. This is at positive 4. So it's from negative infinity to positive 4. And since I put the small, I'm always going to put the smallest number first. I do less than, because my smallest number is first. Does that make sense? Okay. So same thing for here. The lowest point, you go from bottom up. So my lowest point here is -1, -1, and it's positive infinity because look, the parabola is going to go up forever. So it's -1 to positive infinity. Does that make sense? So this, remember, ground up, negative infinity because this goes on forever, right? And the highest point on the y-axis is 0. Got it? So again, less than, equal to. Why I never put an equal to beside an infinity, because infinity doesn't end. So there's no equal right there. It ends right here. So yeah, of course I put equal. Does that make sense? Okay. Are you okay with those? You sure? All right. So now you have your axis of symmetry. Your axis of symmetry is the imaginary line that cuts the parabola in half. So this line goes through the x-axis at 0. So that's why x is equal to 0. This line goes through the x-axis at 1. That's why x is equal to 1. This line goes through the x-axis at what number? What kind of 2? So that's why the axis of symmetry is -2. Does that make sense? Okay. And then your x-intercepts is where the parabola crosses the x-axis. It crosses the x-axis here and here. It crosses the x-axis here and here. And it only crosses the x-axis in one place, here. Make sense? Okay. Last is where it crosses the y-axis. It crosses the y-axis up here. That's where I get this one. It crosses the y-axis right here, crosses at 0, 0. And it crosses the y-axis down here. This is the y-intercept. And so you put that point here. Okay. Oh, sorry. Miss Reyes is tripping. You put that point here, baby. Okay. I apologize. My bad. Okay. Are you okay? All right. So now we're looking to see which of these represents a quadratic function in this form. So let's look at the numbers and see if it's kind of symmetrical. So it's going, you got, this is increasing, but here is starting at 0, down, 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 and keeps going down. No, this is not quadratic.
forward,
Okay.
probably like 30 seconds. So if
Alright,
you
so
guys
this
would
is
like
not it.
to get ready to switch, thank you guys so much.
This
And
is
sorry
going
to
down,
interrupt you.
down, down,
Okay,
down,
okay,
down. It's
bye.
increasing, right? I'm sorry, increase. But look at this. This is small. Then it gets a little bit bigger, a little bit bigger, a little bit bigger, a little bit. It's still not a quadratic function. I can't. It's not going down and then back up again. So this is now no quadratic. Okay. This one is increasing. The x is increasing. So let's see. This is going down. Wait, this where it is. Let me see. This is going down or up, 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 and then, dang, are none of these quadratic functions? Let me look at this again. Yeah, you cannot tell that it's a quadratic function. You can't tell that any of these because they keep increasing. And this is going increase, 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 increase. Yeah, this is a bad example. All right, let's not even do this. When I type it, this one is actually quadratic function here. When you type it in, you can get a quadratic function that's regular, but you can't look at the table and tell that this is a quadratic function. So that's not good. All right, so I will just omit that because that's confusing. All right, so you got it? Okay, good deal. Let me send this video to him.